Welcome to lesson number 5. We're going to talk about factoring polynomial expressions. And so, when we were learning about factoring in pre-calc 11, you might have thought, hey, how do you factor a cubic function or a quartic function? And so that's where dividing polynomials is useful. So if you recall, just this basic parabola x squared minus x minus 6, the function can be expressed in factored form as x plus 2 and x minus 3. And we know that if I have x plus 2, x minus 3, that gives me my x-intercepts of negative 2 and positive 3. And so my x-intercepts here would be 3 and negative 2. And it also tells us what the zeros of the function are, which are negative 2 and positive 3. And the equation would then also have the roots of 3 and negative 2. Now, when we look at all of these, the zeros of the function, if I look at the x-intercepts of the graph of the function and also the roots of the function, well, you'll remember that they're all the same numbers. Okay, so the x-intercepts, the zeros, and the roots are all the same numbers. Now, why is that useful? Well, when we talk about the integral zero theorem, the factors of the polynomial x squared plus 5x minus 24 are x plus 8 and x minus 3. That means that the zeros would be negative 8 and positive 3. And what do you notice about the constant term in the polynomial and the zeros of the polynomial? If we look at the zeros and the constant term, we'll see that the zeros are actually factors of the constant term. So that means that if I take my zeros, negative 8 and 3, I can multiply those to get my constant term, which was negative 24 in that above example. So if we look at the factors of the polynomial of x cubed minus 2x squared minus x plus 2, notice that the constant term here is 2. And the factors are x minus 2 and x minus 1 and x plus 1. If I want to state the zeros would be 2, negative 1, and positive 1. What do you notice about the constant term in the polynomials and the zeros of the polynomial? Again, the zeros are factors. See, if I have a constant term of 2 and my zeros are 2 and negative 1, 2 times negative 1 is negative 2. 2 times 1 is positive 2. So again, they're factors of the constant term. If I were to multiply negative 1 by negative 2, I would have positive 2 constant term. All right, so let's look at examples of where we can actually factor. And if we're looking at factoring, the first thing we want to do is think about what are the potential zeros of any polynomial. And so if I have this this polynomial here, p of x is equal to x cubed minus 7x minus 6, the integral zero theorem tells us that the zeros of p of x must be factors of the constant term of negative 6. And so the factors of negative 6 are plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. All of these values are going to go into 6 evenly. And so this is a list that contains all potential zeros of the polynomial. So in this above example, x cubed minus 7x minus 6, we want to list the potential zeros of the polynomial. Even though they did it before up above, we can still do it here. Plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. Now list the potential factors of the polynomial. If I have positive 1, then the factor would be plus x minus 1. If it's negative 1, it'll be x plus 1. And this trend will continue. If it's positive 2, it'll be x minus 2. If it's negative 2, it'll be x plus 2. Then x minus 3, and x minus 6, x plus 3, and x plus 6. These are all the factors. Now, since we're asked to identify one of the actual factors of the polynomial, Luke uses the factor theorem and Nicole used synthetic division, and their work is shown below. So this is Luke's side. He tried x minus 1 as a factor. And so what he did, since it's a factor, that means the remainder is going to be 0. So or if it's a factor, then the remainder will be 0. That's what you learned last unit with the remainder theorem, right? If any value is a remainder, or if the remainder is 0, then that means that that quotient is going to be a factor of our dividend. And so let's see if x minus 1 worked. So x minus 1, and so for p of 1, Luke plugs in positive 1. And then he multiplies 1 cubed minus 7 times 1 minus 6, and he gets an answer of negative 12. So since negative 12 does not equal 0, or p of 1 doesn't equal 0, x minus 1 is not a factor. And so he tries again with negative 1, and this time with x plus 1 as the factor. And so he plugs in negative 1 into the equation, and he does get an answer of 0. And that means that since p of 1 is equal to 0, then x plus 1 is a factor of this equation. So then the next thing he does is uses synthetic division to get the quotient. Right? So this was where this is x cubed. There's no x squared term, so he uses 0. And then this was negative 7x and the constant term of negative 6. And so he uses the synthetic division to get his answer of x squared minus x minus 6, and then the remainder of 0. And so if you wanted to complete the factored form of this polynomial, then what he's going to be left with is x cubed minus 7x minus 6 is equal to x plus 1, that's the factor, times x squared minus x minus 6. And we can factor this one down a little more. X plus 1 multiply two numbers that multiply give me negative 6, and add to give me negative 1 would be negative 3 and 2. So I'm going to be left with x minus 3 and x plus 2. And then you'll be able to follow Nicole's work. All she did was use synthetic division the whole way through. So first she tried x minus 1, same as Luke. And so she used positive 1 here. And she found out that she had a remainder of negative 12. And then she did the same thing with x plus 1 and found out that what the factor was. And so this way might be a little quicker, just because you're going to be doing synthetic division at the end anyways to find out what the factors are. But again, it's what works for you, right? You don't have to do it either of the ways. If you have your own way of doing it, getting the right answer, that's perfectly fine as well. So let's look at this example. Let's list the potential zeros of the polynomial given that the value of our constant term is 12. So remember, what we're looking for is the factors of 12, which is plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, and plus and minus 12. Now express the polynomial in factored form. Well, in order to do that, we have to find out which one actually is the factor that will give us 0. So let's just start at the beginning with p of 1, and I'm going to try x minus 1 first. So p of 1 is equal to 1 to the power of 4 plus 2 times 1 cubed minus 7 times 1 squared minus 8 times 1 plus 12. So I get 1 plus 2 minus 7 minus 8 plus 12. 1 plus 2 is 3, minus 7 is negative 4, minus 8 is negative 12, plus 12 is 0. So there's our factor. Now since p of x, or p of 1 is the factor, that means that, or is the remainder is equal to 0, that means that the factor here is actually x minus 1. So then I'll plug this into my synthetic division. So 1, and then I'm left with 1, 2, minus 7, minus 8, and 12. Bring down the 1, that's 1. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Negative 7 plus 3 is negative 4. Times 1 is negative 4. Negative 12, and 0. And so for p of x, if I want to express this in factored form, I'm going to be left with x minus 1. And this is going to shift down to x cubed plus 3x minus, or 3x squared minus 4x minus 12. And if you look at this, oh, there we go. If you take a look at what we're left with something that we could maybe factor down even more. And if we're trying to factor it down even more, then the next value we could try is, since it's probably not going to be positive 1, we could try 2, right? And the reason we try 2 is if 1 comes out evenly, 2 might also come out evenly with our constant term of negative 12 and 4x. And so I'm going to try that again just with using synthetic division first, but then using this term as what I'm dividing out. So I'm going to be left with 1, 3, negative 4, and negative 12. Bring down the 1, that's 2. I'll be left with 5, that's 10. Left with 6, and that's 12, and that's 0. So 2, or x minus 2, is our other factor. And so I started with x minus 1 at the beginning. I took out x minus 2, and I'm left with x squared plus 5x plus 6. And if we look at x squared plus 5x plus 6, we can factor that down even more. And so I'm left with x minus 1, x minus 2. 2 and 3 are going to be the 2 factors, so x plus 2 and x plus 3. So what are the zeros here? Well, I have positive 1, I have positive 2, I have negative 2, and I have negative 3. And finally, state the roots of the equation. Well, remember they're the same. 1, 2, negative 2, and negative 3. All right, the other questions are exactly the same, and you can probably do the rest yourself here. The only difference, the only difference is what we want to do here is use the graphing calculator to find out the zeros. And so you just plug in the graphing calculator, use the zeros function, and then you'll end up getting to the nearest hundredth. So just double check this. You'll get negative 1, 0.27, and 3.73.